Hello, astronomers. We are going to take a tour of our solar system. And what I mean by solar system is we're going to take a close look at our sun and all the objects, sorry, all the objects that orbit around our sun. So let's start with the largest object in our solar system. And of course, that would be our sun. So our sun actually makes up about 99.9% of all the matter that is inside of our solar system, all the stuff that is inside of our solar system. So what that means is all those planets, Jupiter, Saturn, Earth, all the rest, all the asteroids, the comets, the meteors, they make up only 0.01% or 1/100th of a percent of the stuff in our solar system. So that means the sun is big compared to the rest of our solar system. Now, what I'd like to take a look at is just the size of the sun itself compared to Earth. So let's pretend that the sun is the size of our planetarium door. Astronomers, if the sun was the size of our planetarium door, take a guess with your hands, show how big do you think that the Earth would be if the sun was the size of our planetarium door? Teachers, feel free to pause the video right now and give everybody a chance to answer. So if the sun was the size of our planetarium door, the Earth would be the size of a nickel. Whoa. The Earth is pretty small compared to our big sun, right? So the next largest objects in our solar system would be the planets themselves. So to see them, let's zoom out and we will let time pass so that we can see the nighttime sky. And let's see if we can find some of those planets. Now, of course, only 5 of our planets are visible without telescopes. And those would be the 5 closest planets to our sun. Now, of course, that excludes us because on Earth, we're actually sitting on the planet Earth. So we just have to look down to actually see it. For the rest, when I say 5 planets we can see, I included the moon in there. So the moon, of course, is not an actual planet, but that is one of the objects that we can see closest to us. So let me look for our first planet, which would be Mercury. And that's going to be below the horizon at this moment. So I'm going to turn the ground off and zoom into Mercury. And as I zoom into Mercury, astronomers, take a moment just to share with an astronomer sitting next to you anything you notice about Mercury or anything you wonder about Mercury. And teachers, feel free to pause the video to allow everybody to share. Now, some things you may have noticed about Mercury. Number one, you may have noticed that it is not full. It looks like it's moving through phases. And yeah, Mercury moves through phases from our perspective here on Earth. Galileo Galilei, the famous astronomer, he was one of the first people to notice that Mercury actually had phases. And of course, that just comes from the effect that we get to see part of the daytime side of Mercury as well as part of the nighttime side of Mercury. Now, of course, Mercury is a terrestrial planet, meaning it has a hard, rocky surface. So we can actually stand on Mercury if we wanted to, but I don't know if we would want to because on the daylight side, Mercury can get up to 800 degrees Fahrenheit. And on the nighttime side, it can get down to negative 290 degrees Fahrenheit. And actually, in some of the craters that are on the surface of Mercury, you might have noticed that it has craters, sort of like our moon. It looks a lot like our moon. Inside some of those craters, there's actually frozen water ice on the surface of Mercury. Now, going back to that note, you might have noticed that Mercury looks a lot like our moon. One of the reasons that it does is it has similar rocks as our moon. Also, like our moon, it does not have an atmosphere. I've read that it has a very, very thin atmosphere that might not even be counted as an atmosphere. But as a result, any meteors that are flying through space can just impact on the surface of Mercury and make those craters, just like on our moon. Size-wise, if we pretended the sun was the size of our planetarium door, Mercury would be about the size of a green pea, the vegetable. And our moon would be just a little bit smaller than that. So, of course, Mercury is our smallest planet. before we get to dwarf planet size. So let's move out from the sun a little bit further, and that will bring us to the planet Venus. So let's see if I can find Venus with my telescope here. And Venus has a pretty close orbit to the sun. So if I have the sun in my view, Venus is probably close by. So I'll zoom into Venus here and take a moment again, astronomers, and share anything you notice or wonder about Venus with the astronomer sitting next to you. Feel free to pause that video. You probably noticed Venus also has phases like Mercury and like our moon. And again, Galileo Galilei was one of the first people to discover that Venus had phases as well. And of course, again, it's because from our perspective on Earth, we can see part of the daylight side of Venus and part of the nighttime side of Venus. So we're kind of looking at a half of Venus right there. Now, Venus, size-wise, it is almost the same size of Earth. So if you remember our little scale we were using where the sun was the same size of our planetarium door, Earth would be the size of a nickel. Venus would be about the size of a penny. So a little bit smaller than Earth, but it's a lot of times called Earth's twin. And in my opinion, it's Earth's evil twin. Venus, in my opinion, is the scariest planet. It has many, many ways to not support life. It is a terrestrial planet, meaning it has a rocky surface, so we could stand on it and walk around, but that would be a terrible idea because at the hottest points on Venus, it gets up to 900 degrees Fahrenheit. To put that into perspective, you may have baked a pizza in your pizza oven at home. That only gets up to 400 degrees Fahrenheit. Well, that would be over twice the heat of a pizza oven, which of course could melt lead. So that's a bad idea to land on Venus and try to walk around. There's volcanoes erupting often on the surface of Venus, so that's even scarier. And because of that, sulfur dioxide is let off into the atmosphere all the time, making the rain on Venus. It does rain on Venus, but the rain is actually made of sulfuric acid. Whoa, which is terrible. It will burn our skin for sure, even though we're fried to a crisp already from the 900 degrees temperature. Also, another thing that would not be fun about Venus is the pressure is incredible on Venus. It's 92 times Earth's air pressure, which would translate to every single inch of our body would feel like a small car was crushing us. That's crazy to think about. So I definitely do not want to visit Venus, but it is a very, very interesting planet. Oh, of course, I didn't mention the atmosphere is incredibly thick carbon dioxide clouds. And of course, carbon dioxide is a greenhouse gas, which traps the sun's heat. And that makes the high temperature. So all the sun's heat getting trapped close to the surface of Venus by its thick carbon dioxide clouds is what makes it incredibly hot. Now, of course, the next planet moving outward from the sun is going to be the Earth. But we are sitting on the surface of Earth. So we can kind of see the ground right here. Yep, we're sitting on the surface of Earth. But our lovely moon, we can see. So let's take a look at the moon really quickly. And we'll actually land on the moon and look back at Earth. But I'll zoom into the moon. So again, you see all those craters on that surface of the moon. Of course, the moon is not a planet itself because it does not orbit the sun. It orbits our Earth. You can see the beautiful full moon right here. What I'm going to do in order to see the Earth is I'm going to land on the moon. So let's go ahead and land on our moon so that we can take a look back at the Earth. We are now landing on the moon. Oh, you zoom out, you can see there's the moon surface there. And I'm going to type into my navigation computer, Earth. So we can take a close look at that. And it's right there on the horizon. Oh, look at that. And we're looking at the nighttime side of the Earth. So let me actually fast forward time so that we can see the daytime side of Earth. Let's see if I can make that happen. All right, so I have fast forwarded time so that we can see the daytime side of Earth. And you can see, of course, all those clouds, land masses, those liquid water oceans Earth is a very special planet. As far as we know, there's not one like it anywhere in the universe that we have found. Um, Maybe some that are similar, but nothing exactly like it. So, of course, Earth is a terrestrial planet. We already talked about on that scale, if the sun was the size of the planetarium door, Earth would be about the size of a nickel. And the Earth is right inside of something called the Goldilocks zone, which means it's not too hot in terms of temperature, it's not too cold in terms of temperature. The average temperature on our planet is about 59 degrees if we average all those temperatures that we experience together. And of course, the atmosphere, 78% nitrogen, 21% oxygen. And then that last 1% is made up of some argon, carbon dioxide, and other different elements. So that is the Earth. Very special place. I'm going to go back and land back on the Earth so that we can continue on looking at our solar system. So let me head back to today's date and time, center us up. And then, of course, the next planet would be Mars. So I've changed our camera here so we can see Mars. Take just a moment, astronomers, and share anything that you notice or wonder with the astronomers next to you. And, of course, feel free to pause that video. A few things you might have known about Mars. It is a terrestrial planet, so it is the last of the inner planets. It has a hard, rocky surface. It would be about the size of a marble on that size scale that we keep talking about. It is red because in the soil it has a large amount of iron content. And of course, when iron comes in contact with water, it rusts. So we get that rusty red surface. Speaking of water, yes, there is small amounts of liquid water on the surface of Mars. I think if you read about it, most of its water is evaporated in its atmosphere as well as frozen on its north and south pole as ice caps. Now, there is liquid water underneath those ice caps, but mostly that ice is made out of frozen carbon dioxide because it gets all the way down to, temperature-wise, on the poles of Mars, it gets down to negative 195 degrees, so incredibly cold at the north and south pole of Mars. But on the equator, it gets to about 68 degrees, which is kind of a nice temperature. Of course, you're going to walk around on the surface of Mars without a spacesuit because the pressure is way too low. Of course, your liquids inside of your body would begin to boil because the pressure is so low. And the atmosphere is not breathable. It's very, very thin, but mostly made up of carbon dioxide, which is poisonous to us. It does have two moons, which is really interesting. You can see the two little tiny dots of moons right here. Phobos, which is a little bit bigger. It is 14 miles across, which is not very large at all. And Deimos, which is only 8 miles across, so super small little moons. But that is Mars. So let's zoom out, and we will head to our next stop in the solar system. After Mars is the asteroid belt. And cool thing about the asteroid belt is in the asteroid belt, there is a dwarf planet, and it is known as Ceres. So let's see if we can find Ceres. I'm just going to type that into my navigation computer. It is down below the horizon, but we'll zoom into Ceres. And Ceres is kind of hard to see. You can see it's a tiny little sphere. It is definitely a dwarf planet. Reason why it is a dwarf planet is it doesn't actually meet all three of the criteria that something has to meet in order to be a planet. So first off, it does orbit the sun. So that makes it a planet. That's one of the rules that it passes. It is large enough to be spherical in shape. So that's the second rule that it passes. The third rule knocks it out of the running for being a mainline planet. It is a dwarf planet because the third rule is it has to be big enough to clear out all of the asteroids in its orbit. Now, of course, Ceres is in an orbit with a bunch of other asteroids inside the asteroid belt. So, of course, it is just a dwarf planet. Now, size-wise, it's only 590 miles across diameter, which makes it about the size of Texas in diameter, which is pretty small for a dwarf planet. The rest of the asteroids in the asteroid belt are about the size of between Ceres, so the size of Texas, all the way down to as small as the size of a school bus. So all those asteroids are floating around. They're shepherded in that ring around the sun by the gravitational pull of Jupiter, which is very, very strong because it's such a large planet. So speaking of Jupiter, let's zoom out and go ahead and find Jupiter in our navigation computer. So I'll type in Jupiter. We will check out Jupiter. Now, of course, Jupiter is the largest of our planets and is the first of the gas giant planets in our solar system. And of course, a gas giant means that it is totally made out of gases. Primarily, Jupiter is made out of hydrogen gas, helium gas as well, which is oddly enough the same gases that stars are made out of. So some astronomers actually call Jupiter a brown dwarf star, meaning that if it had, I want to say the number, look this up, but I think it's if it had about 2.5 times the amount of hydrogen in it, it would actually become a star. Now, it doesn't have enough mass to actually become a star, but it does have the beginnings of heat getting generated down in its core, because in its core, it gets up to 43,000 degrees Fahrenheit, which is pretty wild. It gives off a lot of heat. But up at its cloud tops, because it is mostly clouds up at the top of it, it gets down to negative 235 degrees. One of the cool features about Jupiter is you can see its big red storm, the giant red storm. It's so large that 3 Earths could fit across the center of that storm. Now, speaking of size, if we use that same scale that we've been looking at, the sun is the size of our planetarium door. Jupiter would be just about the size of a basketball. So it is definitely the largest planet, ringing in about the size of a basketball. I'm going to zoom out and you'll be able to see the Galilean moons of Jupiter. So these dots right here are those Galilean moons. And those are Ganymede, Europa, Io, and Callisto. And we could look at those another time. But total moons, Jupiter currently, as of the making of this video, because this number can change, it has 95 confirmed moons. So a lot of those moons are really wild places, but we're not going to go into depth in those in this video. Let's head to our next planet. Next gas giant planet is Saturn. So I'm going to type that in. Or actually, I'm just going to turn on my labels here. We're going to find Saturn just by looking around the sky. There's Uranus, too far away to even be seen by a telescope. There's our friend Saturn. And Neptune is kind of close by it. I'm going to zoom into Saturn. Of course, the most notable thing about Saturn here is the rings. Saturn is a gas giant planet with rings. Guess what? Jupiter also has rings. They're just so faint we can barely see them. Same thing with Uranus and Neptune, but you'll be able to see those when we get to it. So Saturn, of course, it is a gas giant planet as well, mostly made out of hydrogen and helium, just like Jupiter is. And size-wise, on our scale, it would be just about the size of a volleyball. Now, its cloud tops are a little bit cooler. So way at the top of its atmosphere, it's going to be down to negative 290 degrees. But at its core, it's going to be 21,000 degrees Fahrenheit. Now, here's the crazy thing. In 2023, the number of moons that Jupiter had confirmed was up to 145 moons. And you can see some of those 145 moons floating around Saturn right there. As of the making of this video, March 2025, 129 extra moons were confirmed. So Saturn's number of moons now rings in at 274 confirmed moons, which is incredible how many moons Saturn has. Why that is, Saturn has a huge amount of gravitational pull because it's so large, but also it's far enough away from the sun so that it's not playing tug of war with the sun in terms of gravity. So the sun's gravitational pull, which is way stronger than Saturn's, is not stealing its moons as much as other planets. So let's zoom out and check out the next planet in our solar system, which would be Uranus or Uranus, however you would like to say it or pronounce it. The interesting thing about Uranus is it has rings. You can see them very, very faintly. It is tilted on its side. Astronomers think that it's tilted on its side because something may have struck it at some point in the history of the solar system. And as the other gas giant planets are, it is a gas giant planet made out of gas, mostly hydrogen and helium, like the others, but also a good bit of methane, and that's what gives it its greenish blue color. At the cloud tops, it gets down to negative 371 degrees, super cold. But at its core, it gets up to 9,000 degrees. Uranus is actually the coldest temperature planet. Neptune is just a little bit warmer because its internal core gets a little bit hotter. So pretty wild. This planet was actually discovered using mathematics back in 1781. There was not a telescope that was strong enough to actually see it, but it was discovered using mathematics with the gravitational pulls and how the orbits of the other planets were affected by it by a gentleman named William Herschel. And the funny thing about this planet is originally it was not named Uranus. It was named Georgium Sidus, which means George's star. And that was named after King George III. But later on, all the other astronomers said, that doesn't work. We got to name it after a Roman god like the rest of the planets. And they named it after Uranus, the Roman god of the sky. So Uranus has 28 moons. And you can see some of those kind of sprinkled around in this photo here. But we won't get into those at this point. So we're going to head to the very last planet. And that would be the planet Neptune, which, just like Uranus, is so far away that you cannot find it unless you have a incredibly powerful telescope. So just like Uranus, it was discovered using mathematics and then confirmed, or it was proposed that there was a planet out there using mathematics and the gravitational pull of something large was affecting the orbits of the other planets. And sure enough, using very large telescopes back in the late 1800s. So Neptune was discovered in 1846, and it is, of course, made out of hydrogen and helium gas with some pretty large quantities of methane in order to give it that bluish color. You can see its great dark spot, which is a storm that contains the highest wind speeds in the solar system, ranking it at about 1,000 miles per hour, which is pretty wild. You can see right there that line that is the rings around Neptune. And Neptune, I mentioned, is actually a little bit warmer than Uranus. At the cloud tops, it's negative 353 degrees, which Uranus was negative 371. And the reason for that is the core of Neptune is hotter than the core of Uranus. It's at 12,632 degrees Fahrenheit, whereas Uranus was only 9,000 degrees. Now, Neptune has 16 moons confirmed. You can see some of those right there. All right, so that leaves us off with all of our planets being taken a look at by us. But there is, of course, one last dwarf planet. You guys are probably asking for it right now, which is Pluto, of course. Now, Pluto, yes, at one time it was considered a planet. Let's see if we can zoom in very far. It's so far away that we can barely see it with this really powerful telescope. Yes, Pluto is a dwarf planet. It is about half the size of our United States in diameter, so super small. The reason why it is a dwarf planet is it is round in shape, so it meets the first rule of being a planet. It does orbit the sun, so it does meet the second rule. However, it is inside of something called the Kuiper belt, which is a second asteroid belt, which means it does not meet the third rule, which is, in order to be a planet, the object has to be big enough to have cleared out all the asteroids in its orbit. Pluto has definitely not done that because it's inside of the Kuiper belt. Now, something interesting about Pluto, it actually has 5 moons. Some of them are kind of larger. The largest one is called Chiron, and it is about half the size as Pluto. I'm actually, in order to see Pluto close up, we're going to land on Chiron. So here we go. We're going to land on Chiron. And for some reason, my software is making the ground on Chiron green. Why that is, I do not know. But check this out. You can see the sun is so far away that it almost looks just like a normal star, like any other star in our galaxy from there. So I'm zooming into Pluto, And let's see if we can fast forward time to get a better look at Pluto. Get a little bit more of the daytime side of Pluto facing us. I'm just speeding up time there. So we can see Pluto's rocky surface. There is a lot of ice and snow on the surface of Pluto. And there's really one really cool feature, which is this white heart right here, or light colored heart. So Pluto has a little heart shape, which is kind of neat. So again, Pluto is a dwarf planet. It also, out in the Kuiper belt, it shares that space with some other dwarf planets, such as Amea. You can look that one up, spelled with an H. Maki Maki, spelled make make, is also out there. So definitely check out those dwarf planets. So that has been our solar system. I hope you enjoyed it, and definitely any of the questions that you all asked during this time, make sure that you record those somewhere so you can go back and look up that information. I hope you had fun. Thank you so much for joining me. Y'all take care.